This is our point C. Sorry, point B. All right, this is our point B. Right, and then at our point B, we know that we have a force. So the first thing to sort out is all your loads. Okay, so we have point B at 120 times 10 to the power 3, right? And then we have a shear force. Because we are analyzing from left to right, now V is a function of X again. Okay, moment as a function of X. Okay, so later on, when we analyze, we're going to analyze at a certain distance, X. Okay. Now, remember what I tell you, okay? Sort out all your distance first. If you don't sort out your, we have another load. So we have another load acting on the center because it's evenly distributed, right? So it's evenly distributed. You have a load down here. So this will be 50 times 10 to the power 3. And now it comes back to X, right? Because it's a range, we are going to form what? Equations, right? It's a range. We're going to form equation. Okay, so from here we are going to draw our distance now. Okay, so we know that our slider, we are going to slide from here to here, right? So this is our X. Okay, and then we know the distance from here to here. Things get more, I wouldn't say difficult. You have to add in more detail, right? So this is 0.8. Right? And then the distance from here to here, can anyone tell me the distance from here to here? Is it X minus 0.8 or 0.8 minus X? Can anyone tell me? Hello? Is it X minus 0.8 or 0.8 minus X?
X minus 0.8.
Yes, absolutely. Thank you. Okay, this will be equal to X minus 0.8. Why is that? It's because this region over here, the number has to be what? Positive. Okay, it cannot be what? Negative. If 0.8 minus X, right? You always be a what? A negative number. Negative number means you're calculating on the left-hand side of the shear force and bending moment diagram. Okay, and then we know from here to here now the distance is what? Is X over 2. Once you sort out your distance, everything is easy, and your forces. If you don't sort out your distance, you will get lost, okay? Because I got lost before, and now I am found. I'm telling you, it's amazing grace, okay? So positive. Again, we are going to do static analysis. Okay, from left to right. Okay, see again, the sequence repeat itself. Forces in the y direction is equal to 0. Okay, so summation. So we will have a minus 50 times 10 to the power 3, right? Then we have a plus X plus by 120 times 10 to the power 3, right? Minus by V as a function of X, the whole thing will be equal to 0. So V as a function of X, this will be equal to minus 50 times 10 to the power 3x plus by 120 times 10 to the power 3. Okay, so this is what we see. Okay, and then we are going to form our moment equation again. Okay, so we are going to form our moment equation. Summation of moment in the on the z-axis as a function of x, the whole thing will be equal to 0. So this will be equal. So you have the evenly distributed load is rotating in an anti-clockwise direction, so it's positive. So 50 times 10 to the power 3x, okay, bracket x over 2, right? Then the 120 times 10 to the power 3 is generated clockwise, so it's minus 120 times 10 to the power 3. Then you have x minus 0.8. That is why it's so important to sort out your distance. Once you sort out your distance, everything is easy. Or not, you'll be like, you got, it's like constipation, yes or no? You don't know whether is it right or wrong, right? So this is plus by m as a function of x. Then the whole thing will be equal to 0. Okay. So m, excuse me. So m as a function of x, right? So you open the bracket, everything you take out. So you have minus 25 times 10 to the power 3 x squared, right? So minus you bring over is plus. So this is plus by 120 times 10 to the power 3 x, right? And then minus minus plus, you bring over the other side is minus. So 0.8 multiplied by 120 is equal to 96 times 10 to the power 3. Okay, so you have two equations now.
Okay. So if I'm not mistaken, correct me if I'm wrong. All we're doing here is calculating formulas that then you can use to calculate any point that you're interested in.
Yes, yeah, absolutely right. And also you now have the confidence to sketch your shear force and bending moment equation based on the math and not based on experience anymore. Right?
Okay.
Yeah, so usually those of you, I know this is not a new topic to you. The only thing new to you is forming the equation. Why we form the equation is because later on, then we can calculate deflection. Okay, because if you don't form the equation, you cannot solve the deflection issue. Because after this, we are not going to assume that the beam is a rigid body anymore. You guys remember we used to assume that the beam is a rigid body, that the beam will deflect in a straight line. After this, we are going to integrate 2 more times to find the deflection. And once you get the deflection, the beam now is not deforming in a straight line. Like for this case, how would the beam deform? I'm going to sketch for you. The beam is going to deform in this manner. The beam will deform this way. So it's going to do this, and it's going to come out. Yes or no? I just drew how the beam is going to deflect. And that is the real world. Okay, not Mickey Mouse stuff. Okay, not crappy Mickey Mouse stuff that we used to do. We're gonna assume that it's a rigid body. No more. Okay, when I was assuming rigid body, I was making your life easy. Try to encourage everyone to do the analysis. Now is the money time. Okay, when you finish this course, you can design a bridge. Okay, now question. The thing about whether a student can get very good grades or grades that are not so great is nothing to do how smart you are. It's the fact that can you check your answer whether is it right or wrong. Okay, nothing to do how smart you are. Do you know how to check whether your answer is right or wrong? Okay, now I'm going to teach you that before we go for a break. Now for this case, we like I don't know whether is this equation is right or wrong. So now what we are going to do is we're going to substitute when x is equal to 0.8 into the equation down there. We're going to substitute x equal to 0.8. If we substitute x equal to 0.8, we should have the same answer as this. Okay, so we're going to try. Okay, we're going to try. And later on, you'll know why we check this way. So this is minus. So when v is equal to 0.8, this is equal to minus 50 times 10 to the power 3 multiplied by 0.8 plus by 120 times 10 to the power 3. So this will be come out as what? So minus 50 power 3 times by 0.8 plus by 120 power 3 is equal to 80. Is it the same? It's exactly the same. So now if we do with the bending moment, okay, we do the bending. How do we know that this is correct? Not this one. How do we know that this is correct? Right? So this is equal to minus 25 times 10 to the power 3 multiplied by 0.8 squared plus by 120 times 10 to the power 3 multiplied by 0.8, okay, minus by 96 times 10 to the power 3. So this will be equal to minus 25 power 3 times 0.8 times 0.8 plus by 120 power 3 times 0.8 minus by 96 power 3 is equal to minus 16 times 10 to the power 3 Newton meter. That is how we know it's correct. So between students that has very good grades or not good grades, nothing to see how smart you are. Do you know how to check whether your answer is right or wrong? That is where the good student comes in, or that's where good marks comes in. Now, before I stop for a break, I'm going to ask your question. How y'all like the screen now? Is it better now or no? Can I have some feedback? Any, is it better? But the words are smaller for you guys, yes or no?
The what?
The